And this global webinar is sponsored by both Institute of Analytics USA and Madras Management Association. And also, I have a very exciting information to share with you. All our certificates are jointly certified by both Institute of Analytics USA and Madras Management Association. And Institute of Analytics USA has offices in both USA as well as in India, in Chennai, especially in Chennai. The recommendation engine, is so fundamental, so important in a digital world, in a digital store. It's so popular, and some of the, I have examples here like Amazon is using it, Flipkart is using it, Netflix is using it, Twitter, Facebook, of course, YouTube, New York Times and the Hindu. And if I can rank, who is doing a phenomenal job utilizing recommendation engine, even though everybody needs it equally, everybody needs it and they will benefit by it because they can personalize their services, their products, and whether it is in information products or the physical products. Okay. I would say in terms of ranking, I would say way ahead is Amazon and Netflix. They are in the same rank. Facebook with its billion users, I'm very surprised that they are not doing as good as Amazon and Netflix are. This is my personal opinion based on my personal experience. Facebook might publish or others might publish saying that, oh no, Facebook is doing a phenomenal job. It's possible, but then the way it is serving me, I know it's not useful for me. Now, of course, YouTube is great also. So I would say Netflix, Amazon, YouTube, even Flipkart is to an extent it belongs to the top level. Okay, but Flipkart is not as great as Amazon and Netflix are. The Twitter is getting there nowadays. No, I am getting messages saying that somebody, person A and B, A is following B who has 10,000 followers, and if they are in my area, I would certainly appreciate. But I find that sometimes they are not really in my area. My area is data science, computational algorithms, automation, AI, machine learning, and so on. The New York Times and the Hindu, very interesting. New York Times, I have seen it in the past, but not all the times I see. Hindu, I don't see it at all. Interestingly, Hindu provides a space at the bottom space for advertisement company called Outbrain. Outbrain does a phenomenal job. Once I click to some intriguing stuff, boy, then I start getting all kinds of interesting stuff. So that is a problem also, right? Sometimes the people overdo it. LinkedIn also does a very good job. I could have included LinkedIn here. Okay, very good job. So that's the kind of ranking of this, how these people use it. What I want to tell you is everybody needs it. In fact, Amazon says that almost 20 to 30% of their sales are happening because of recommendation engine. The reason is very simple. When you have a large tail distribution of the products stock list, by that I mean million plus products, right? For example, 100,000 plus, 120,000 plus movies in Netflix, millions of products in Amazon. How are we going to sell? People don't have time to search. How are they going to get the attention of the bottom 80% of the products, or even 95% of the products, right? So that's where the recommendation engine becomes very powerful. So in the case of Amazon, they sell approximately 30% of their 20 to 30% of their revenue comes from recommendation engines. So it's very important. And not only that, if you want to optimize your website, website has a lot of multiple framework boxes, and they constantly test in terms of what to show to a visitor. That is the recommendation engine, basically. What to show to your visitor. That should be personalized. That should be interesting, relevant to the customer, right? The visitor. And that is also based on, basically based on the recommendation engines. So it's fundamental whether whether you have purely a store or some kind of a services like news services or social media services and so on. So let me quickly go over Amazon. This is an example of Amazon. It's very interesting. Almost, I would say, 75% is, I'm interested in the search space, right? So I am interested in technology and laptops, the desktop. Recently I've been, searching for that, so that's why it's there. Hi there and that. They are referring to me. Hi Netra, welcome, and these are things you would like to. I hope you like, and so on. And then there is I searched for Amazon devices, Amazon devices, office products. I search for office products, and sometimes the delivery is important for me. Immediate delivery is important, so they keep telling me about Amazon extreme delivery possibilities. Summer is here, so they give summer. This one is very interesting. The Whole Food. I used to search in Whole Food, right? Whole Food is about good food, and organic food and fresh food and so on. So I have searched in the past, but very long time back. But I don't know how they got this one showing me, and probably there is some recent info. Yeah, recently I have searched for okay, I searched for cooking items. Maybe that's what it is. So this is interesting. So I would say overall it's great. Okay, great combination of show here for me. The 3D printing is here and so on, right? Okay. Now, Flipkart is somewhat coming closer to it because their experience with me is not that much compared to Amazon. But I did buy some technology items, in Flipkart, some, books, school-related items, and so on. So, so equipment and so on. So that's why they show it here. But I will still rate it lower compared to, because they don't have that much experience compared to Amazon. Okay. Netflix is great. Look at this one. Because You Watch Africa. Hunt is there. Frozen Planet is there. Life is there. Very interesting. These are all interesting for me. Absolutely, I am interested in this. In this one, how the trending now. I don't really care about. I don't know what it is. I don't care. I don't care about this also. But how it ends is a intriguing title, plus it is a thriller. I just read that what it is about. It's a thriller. Looks like a thriller. So I am interested in this one. So it ranked high. That's good. In this one, I'm kind of interested in very interesting here TV dramas. I'm interested in old type of historical type of TV dramas. I like them, so it turns out to be good here. So all good here, good here, good here, and these two, this and this, I don't really care. But you don't expect 100% what you care, right? So if it is 70, 80%, if they show what you like, that's great. So what I'm going to do is, I'm going to show you the mathematics, so the calculation of, similarity measures, which are fundamental in finding out the product purchase patterns that I haven't exhibited yet, but is going to be most likely because I resemble like other people in the rest of the product purchases. Okay, in the rest of the product purchases, I resemble like some people, and we take the most correlated people, such people, and then find out their behavior and their average behavior is being posted to me, thinking that the remaining part of the behaviors I will continue to resemble like those people. So that is what the similarity approach is. Similarity measures are calculated, and I'm going to show it to you a little bit. If I open this file, it has many things, but then I'm going to consider only for this immediate explanation. I'm considering a situation of there are 8 items. Okay, these are the 8 products, for example, and there are 6 users for which I have data, and they ranked the importance of the product, those products to them. Like for example, the user 1 ranked very highly, up to 5, 1 to 5, ranked a liking of 4. Product 3 is ranked to liking of 4. Product 4 is like given a ranking of 2 in terms of liking. It's not really that much liking. And then product 5 is given ranking 1, absolutely not interested at all, type of information. So, and then finally product 6, user 1 ranked it as, in terms of liking 2 out of 5. 5 is the best. Okay. Now, he or she doesn't have any did not provide any information about product 1 and product 7, product 8. So like that, I can interpret each one of these users' experience. For example, this user number 6, basically it doesn't care about any one of these things, basically because he or she gave a ranking of 1, 1, 1, 1. 1 is not the best. 5 is supposed to be the best. Okay, most likable, most important to that individual. Now, this is a given data, okay, in the system. Now, Tim, a select customer is, we want to find out what kind of the products that we can recommend. Can we, among the products that he hasn't experienced, the product that he hasn't experienced is I1 in product 1, product 2, wherever I have the question mark, product 5, and product 10. He hasn't experienced that at all, so he hasn't given the information. Now, among these 4 products, which one is most likely to be recommendable? Which means, the one which will have score 3 and above, 4 and above, 4 and 5, which is considered to be likable. If I make it as a binary measure, 4 and 5 is liked, thumbs up, and 1, 2, 3 is thumbs down. Okay, let's keep it that way. So, what kind of score we can give here, right? So what we are saying is now take this vector, and find out the most closely related vector, product purchase likability vector, which are scored as 1 to 5. This vector, which is close, is this vector most closer to this one, or this one, or this one, or this one, or this one, right? But here is the thing. Okay, that is the first part of it. Just calculating the similarity measure, that is a closeness, okay, or correlation. The second part of the calculation is you are not just taking one person who is closest to this, to this vector of preference exhibited by Tim. We are talking about collection of people now. So we are going to take a neighborhood of 3 people who are closest to these individuals, the rest of the data, right? Who are closest to this vector. 3 of the individuals, and their average scores I will be posting it. That's the problem is as simple as that. Okay. So I want to stop here and follow to the more details about this Excel worksheet and explain those calculations. The point is now you understand what is meant by items. The items people buy. There are 8 number of items. 8 items I'm going to bring in for calculations, and there are 6 people there in that slides. I showed you 3 people, right? Red. We talked about, let me go back. Yeah, red, orange, green, right? No, I'm not going to talk about 3, but I'm going to use 6 people. So there are 6 users, okay, and there are 8 items. This small data, it's bigger than what I showed you about, those 3 colored people, but here it is. Users are 6 people, and then there are 8 items. Okay, in this one, they are giving you some ranking about their liking. Okay, their liking. So it's a 1 to 5 liking number. Liking, that is, it's not just thumbs up, thumbs down, thumbs down, but 5 means the best, 1 means the least, something like that. Okay, so they give you a ranking. So for example, user 1, it may be Netra Sambamurthy. He didn't buy item 1, but he bought item 2, item 3, item 4, item 5, item 6. Boy, he's buying a lot of stuff, right? Okay. And he liked item 4. Item 2. He liked better than item 4 because he gave a ranking of 2 here and he gave a ranking of 4 here. Item 5, of course, he doesn't like that. Oh, it's just okay, right? So item 2 and 3 he likes most, let's say. And he didn't buy item 1 and item 7, item 8. And somebody else, let's say Sam bought item. Why Sam? Ram. Okay, not Ram, Rom. Okay, Ram bought item 1 and he likes. He gave it, he gave a liking of 3. Okay, the coded word liking, code number 3, which means better than average. Average is 2.5. And then he bought item 5. He gives 5. Okay, he didn't really like that much. Item 6. And he didn't buy item 7, item 8, item 2, 3, 4. These things he didn't give any information. Either he didn't buy it or he didn't give information. But let's consider that he didn't give information. Okay, I'm sorry, he didn't buy that product. Likewise, Arun, user 3. Arun bought item 1 item 5, item 6, item 8, and he gave these ratings also. So likewise you have 6 people. Now you have a new person, you are selecting somebody new. You want to know, based on this data only, you want to know what kind of liking he is going to have for item 1, item 2, item 5, and item 7. So that is the problem we are trying to solve. Okay, so let's say this is Tim, right? Tim is he has bought and he has given ranking for an item 3, item 4. That's why I color coded this way vertically. Okay, those are things he bought and he has given a rating here. Okay, but he didn't buy yet item 1, item 2, item 5, and item 7. Okay, the question is, what kind of rating Tim is going to have here? Most likely rating Tim will have for item 1, item 2, item 5, and item 7. That is what we are trying to calculate. So it should be a number between 1 and 5. Okay, it should be a number between 1 and 5. Is the problem clear to everybody? Just say yes or no. I like to check here and there. So just in the chat area, just say are you clear about about the problem? Okay, Gokul says yes. Anurag says yes. Give me yes, man. Or just say yes. Your encouragement is what makes me get excited here. Thank you. Thank you very much. I got only so far 6 people, 25 people, 24 people are here, including me. All right, thank you. So good, it's good. So overall, I see that everybody is understanding. If you have any, if you don't understand, you can say no. Can you please explain one more time? That's fine. Okay. Right. Excellent. Very good. So far, I got only yes. So I take the rest of them are yes too. Okay. All right. So the problem. What is the problem? We are trying to fix these numbers based on this data only, nothing else. Okay. Very simple problem because I have not too many data items other than this. Okay. Now, thank you very much, Mr. Kiyoshi. All right. So the way to do, logically think about it. I'm going to just say logical idea only right now. I'm going to say whoever looks most among these people, whoever looks most similar. For Tim, I take Tim and I compare with, who is very similar to Tim's selection with respect to his other items. In other words, he has given number, grade of 4 or the liking of 4, liking of 3 here, liking of 1 here, liking of 5 here. Based on this data only, partial data, of course, who is going to be most similar to him in this list of 6 people? And I will say, whatever he says, I will post that ranking for this guy. Does it sound reasonable to you? No, I don't want you to give the answer. We will come to that. Some of you are saying the answer. What I'm saying is, the most, who is resembling most, I'm going to take that as the best possible collection of posting. I can post it to this guy. Okay. So some of you are saying U4 is very similar, and we'll see. Okay, but alternatively, what I can say is not only the best one person, but collection of closest to few people, maybe 1, 2, 3, 4 like that. So we will fix the idea for our calculation. 3 people who are closest to him, we will take an average of that and post it there. How does that sound? Is it better than just looking for one person? We will take, the closest number of people. You can just say yes or no. That's okay. Or yes or I don't understand. Okay, sounds good. Okay, I didn't just say something. So what did I say? I'm going to take the most similar people who are closer to this guy. Tim. This is Tim, right? A select person. Select customer. So I take Tim or the select customer and find out who is most similar. And then not all of them, there is going to be ranking there, okay? Maybe U2 is the closest, next is U3, next is U6, and so on. There's going to be some ranking. But I take the top 3 people and average their score and then post it to this person. Okay, that is our strategy. Okay, sounds, I think, overall Few people said, agree or say yes. So sounds good. And only 2 people. So I hope everybody agrees with that. That's a fundamental idea here. If you understood that, you know recommendation engine. It's only now a matter of calculating it, using some formula and then posting it in the database. That is the fundamental idea. Okay, now let's. So now I have to fix what kind of formula to use. Okay, that's all to it, right? 2 places I have to actually. Well, there is only one place, but 2 places I'm making the calculations. One is what is meant by closeness, similarity. Okay, that is one place I have to do the calculation. The second one is what is meant by neighborhood averages. Okay, what is meant by neighborhood averages? If I do those 2 calculations, I have finished and completed the answer. Okay, so I do simply what is called cosine similarity. Cosine similarity, which is defined like this for a vector, 2 vectors A and B. So this is a vector, okay, and I compare this vector with all the 6 vectors, right? So let's take any one of these as B. Let's say if U1 is B, A is this one. So I find this similarity between these 2 vectors, which is calculated mathematically like this. Okay, A dot B, that is a dot product. Okay, it's also called product sum. Dot product is same as vector dot product is same as product sum in Excel. Okay, and this is square root of sum of squares, which is also self product sum, right? But you take a square root of that. Now, very interesting here, something is going on here. I am pretty sure all of you know what is meant by correlation coefficient. Okay, I'm pretty sure everybody knows correlation because you all know a little bit of statistics. This is actually very close to correlation coefficient. Do you agree with me? Except for the n. Everybody agrees? Say yes or no. It's just correlation actually. Why do they give another name? I don't know. It's because I can only hypothesize to you why people give. Why can't they simply say correlation? There could be many issues, but one issue is that please respond, okay? Because I know my connection is live. You're all engaged. You're all kind of engaged in the conversation. You're focused here, okay? So this is. Anybody kind of questions this? This is similar, very close to correlation coefficient, except for the denominator n on both sides. Okay. Now, so basically, cosine similarity is what I'm going to calculate. There is one important advantage in cosine similarity. That is, if the value is missing, don't worry about it. That particular product, is 0. Okay. So it is a product sum. Remember, this is a product sum. Keyword, keep that in mind. This is a product sum. Okay. And this is basically product sum with self-product sum, which means square it. Because if it is A with A dot A means AI square, right? That's what it is, self-product sum. So I'm kind of used my own terminology there, but let's take a look at it. So what I'm doing is now I take this, do the product sum here. That's what this calculation. Do you see this one? I don't know whether you are able to. Well, let me see. How about this? You are able to see, right? It's product sum of D4 to D8, D4 to K4, I'm sorry, D4 to K4, okay, not D8, D4 to K4. Product sum of D4 to K4, comma, D11, this is D11 to K11. So this is the product sum, right, divided by square root of sum of squares. You can put sum of squares or product sum again also, you can do it, doesn't matter. Sum of squares, so sum of squares of this and then square root of sum of squares of this. That's basically your cosine similarity, right? I calculate that. I apply that. I calculate it's 0.52. And similar to correlation coefficient, here also it will be between 0 and 1. Okay. Oh, minus. It cannot be minus. In this case, it won't be between -1 and 0 because all the numbers are positive. Okay, all the numbers are positive. So this is the calculation I make. And what is this? This calculation means this is a similarity measure. How similar this guy, the Tim, right? I call this guy as Tim, the select new customer, right? Tim, I select, I want to find out how similar Tim is to each one of these guys. And I find out that that similarity can be given a number of 0.52. And how similar Tim is with respect to U2, I do the same thing. product sum, look here. Product sum, right? Sum product, minus divided by square root of sum of squares star square root of sum of squares. Right? But I'm working with respect to U2 and this guy, Tim. U2 versus Tim. It so happens that U2 is highly dissimilar, right? Highly dissimilar. Okay. But U1 seems to be pretty close, right? Somebody said actually U1 and U4, and you guys are awesome. Look at this. You did some mental calculation. I think you did a good job. Can you show the Excel calculation again? Yeah, sure. So I'm doing basically sum product, right? Of 1 second. Sum product of, I take two vectors. See, I take Tim's vector and do the sum product with this, and but I want to normalize that, standardize that, or normalize that. So I take a square root of sum of squares of this times square root of sum of squares of this. That's what the cosine similarity is, right? So I calculate that and then post it, and that's what 0.52 is. And what I was saying earlier is that is that clear? Is that okay? Please respond. So I was really impressed. Some of you said actually, U1 or U4. You gave an answer, right? Good. It turns out to be that your numbers, your expected, your answer is good, correct in this case. Okay. But dissimilar one is U2. Now, so I got this fixed, right? I got this fixed. I got, what did you say? What do I mean by I got this fixed? I have found the similarity measure of Tim with respect to each of the users in the set. Similarity measure of Tim with respect to users in the set. Okay, so I have done that. So, and Tim is very similar to U1, U4, and U3. The most similar to U1, U4. U1, U3, U4. U1, U3, U4 is the most similar. That's why I highlighted it into kind of light blue color. Okay. Now, so what is the answer? It's not over. It is just now I got the similarity, right? How I got the similarity indices of various people, how close they are to Tim. Now, what I am going to do is among, now I have to calculate what is the score I have to post here. The score is not yet done, right? I have to put the scores here. That's what I want to do. So what I am doing is, we take the average of these individuals, okay? So look at this one, D4, D6, D7. What is D4? D4 refers to average of D4. I'm going to take, I told you that I'm going to take 3 people in there, whoever is closest to 3 people, I will use only those people's score to post it as average score. That is the second part of the calculation. Okay, I take 3 people to calculate what is the expected score that I can put for this, for Tim's, what I expect Tim to score with respect to the item I1, item 1. For item 1, what Tim is going to put as score, I'm going to estimate that based on 3 neighborhood people only, okay? The neighborhood, who are very similar to him. Very similar to Tim, and we know that very similar people are U1, U3, U4. So we are going to take the average of those 3 people, and that's what we are going to post here. You see this one? So for I1, let me show the formula. I1, we know that we are going to use these lines. It's very clear, right? Only those three lines, those most closest people, most similar people, 3 people, and their average I'm going to put. So this is going to be, it's very easy, right? 3.5, isn't it? Because we don't use the, whenever it is missing, you are going to put it as, treat it as 0. And the condition, the average in Excel does that automatically. So it is 3.4. Now, what is this one? You are taking this, so it is going to be 4, right? But the formula is same. So I just copy and paste this one, I get all these answers. So wherever it was missing, I put it as in red color. Is everybody clear now how I got the numbers expected scoring by Tim? Everybody got it? Anurag says, cool, very good. He says, yes. Say yes, if you understood it. Okay, yay, that's good, Gokul. Thanks a lot. Excellent. More yes, any no is better. More yes is good. Thanks. All right. Um, so I fill up doing this again and again. That's it. No, I can scale it to millions of records. That's all to it. No, I may not have k nearest neighborhood is 3. I might use it, 20 or 10 or 200, right? But the point is, these are the only two simple calculations for recommendation engine. It's amazing, isn't it? But it can get complicated. We'll come to that later. Okay. Now, this is user similarity matrix. I can also do item similarity, isn't it? So here we go. Everybody gets the idea now? I jump to item similarity. I can do the item similarity also. Everybody agrees? Everybody understands? I did so far user similarity, but I can do item similarity. So I'm talking about this way, column wise, right? So I can fill up this information again. Same similar type of calculations, the cosine similarity. Everybody understand this, what I'm talking? At least one yes. Okay. One yes. More yes is better. Okay, thank you. All right. So let's go to this now. Now that we understood, please zoom the Excel. Okay. Well, it's almost over now. It's over. Okay. I'm moving to R calculations. I'm going to talk to you about movie recommendation. Now we'll take a big data set, thousands of observations, and do this calculation, and then close it. Okay. Our session. Okay, so I'm actually using a code from this guy, Muffy Nomster, but we actually corrected many things here in our own way. Jake, my colleague Jezreel, and I did this, some changes here, so that it works. There was some problem with that. Now, are you able to see my R screen? Everybody? Type yes or no. Yes, okay, Google says yes, thank you. If one person does it, I take the message that no, you're all able to see. All right, so there are 4 data sets. These are all CSV files, okay, movie files, movie CSV file, ratings, links, and tags, okay. I'll explain those things to you. Here is the data set, okay. I need to make it bigger for you. It's not, you're not able to see, I guess. One moment. I hope this is better for you now. Okay, 200. I don't know whether it is showing up bigger here. Are you able to see this one? First one is links.csv. Are you able to see that? Links.csv. I try to make it bigger, but it doesn't become bigger. Okay, no, it doesn't make. I don't know why. the names don't become bigger. Okay, I want it to become bigger, but it's not. All right, my point is there is links.csv rating, so movies.csv. There is 4 CSV files are there, right? That's what I'm reading now, right? Okay, where is that? Here it is. Okay, so let's read this. I'm basically using the read.csv. Okay, run. It ran. Okay, so I can actually open that file and show you what's going on there. All right, so here it is. Okay, there are 9,125 observations with 3 variables. Okay, what are they? So here they are. You can see movie ID, and then are you able to see this, everybody? It's a little bit smaller in size. Okay, thank you. So movie ID 1, title is Toy Story, and then what kind of genre is that? It's adventure. There are many ways they describe it: adventure, animation, children, comedy, fantasy, and so on. So there are 5 ways they describe it: adventure in terms of genre. Okay, and then number 2 is movie ID 2, Jumanji. It is also adventure, children, and fantasy. I have seen both these. Grumpier old man. I haven't seen. It says comedy and romance. Number 4 is this is the movie. Number 4, Waiting to Exhale, comedy, drama, dance, and so on. Okay. I have seen this Heat very long time back. I saw this Heat, action, crime, thriller. These are all good. Okay. Now that is about the movie data set. So there you have movie ID, title of the movie, which year it got came out, and what type of genre it is. So there is a lot of information mixed up here, right? With the pipe, separating these words by pipe symbol. So we have to separate out so that we can analyze them. With pipe symbol we cannot analyze. That means definitely it is a mixed collection of words, right? So let's see. So that is one thing I did, right? Now I am going to read. Where is the genre? Network principle. There is a DB scan recommendation engine. Okay. Now I read the other things also, ratings, links, and tags. All of them I'm going to read it right away. Done. Okay. Now I can go back and show you what those files are. If I showed you movies. I'm going to talk about next ratings. Okay. Ratings is here. So user ID. So what is meant by ratings? Yeah, user sees a movie. So there must be user ID and the movie ID, and then whatever the user gives the rating for that movie, right? So user ID is 7. For the movie 1, Toy Story, he or she gave a rating of 3, and when they did is the timestamp. Okay, those are the 4 variables. All right. Now we are talking about another data set, links. So we talked about movies and ratings. Let's go to the links now. How are you doing in terms of time? We are doing good. Links. It's not here, so I'm going to double click here. It is here, so okay, here it is. Links. Links. View links. No, this is some other thing. I'm going to go back to this one. Links. 1 second. Let me go and see the data set. What does the links mean? Okay, that links is not the right one. I have to remove that one, and this is what it is. That is, it is a link between. There are 2 databases: Tomato movie database and then IMDb movie database. There are 2 databases, and we need to. Sometimes it is useful and important, and we won't use that in our analysis. But I just read it because it's part of the data set. So in Tomato movie database, it's called Tomato. Okay. Tomato movie database, it is 862. Toy Story is ID. Toy Story, the ID of Toy Story in Tomato database is 862, but in IMDb movie database it is 114709. Okay, so it's just a link between those 2 databases. We don't need to worry about it, but I read it because it is there. Okay, as part of the code. And then the tags. Okay, let's see the tags here. So here is the tags 1296. So here it is, the user ID. They give tags or the keywords. Okay, for example, movie Toy Story is a Pixar movie. Okay, which is owned by Steve Jobs. He created that Pixar company, and then it got bought by Disney. So it's a tag. Okay, so it's a Toy Story. One of the keyword that is relevant for that movie. These are all keywords relevant for each of those movies. Okay, so Toy Story is a Pixar keyword, and then ID 5, movie ID 5 is Steve Martin. Okay, movie ID 5 is Father of the Bride 2. Everybody knows that Steve Martin, very famous, right? It was a very successful movie. That's why they took part 2 also. Okay, so Steve Martin is a very important keyword. Okay, everybody agrees. I agree. All right, I think you will agree too. All right, so 47. Let's just go to 47. These are the multiple number of keywords I use: biblical, crime, dark, disturbing, greed, horror, serial killer, violent, psychology, twist ending, all those keywords. Okay, let's see what this movie 47 is. Okay, 47 is 7 aka SE, number 7 EN. Okay, mystery and thriller. Yeah, those are all good words. Okay, good words that captures the movie's characters and characteristics. So we understood the data now, and we want to do the recommendation engine, right? Recommendation engine to somebody who hasn't seen that particular movie. I might not have seen out of this how many movies I have. Let's say 9,000 movies, 9,125 movies are no. Once again, sorry. It's movie ID. Yeah, that is correct. Movie ID. But movie ID is not sequential. Okay, the index is really this one you have to use. 9,125 movies are there. So I might not have seen all. Definitely not 9,000 movies I saw in my life. So I might have seen 100 movies. Then what are the remaining movies? The next best movies. The system can recommend. That is the idea, right? The next best 10 movies that the system can recommend. That's the problem we are trying to solve. Okay, so we did that. Let me go back to the R codes. Recommendation engine. So, the first thing you should do always when you do R is, you want to look into the data and what are the different variables. I kind of went into it, visually I went into it. You can do this structure command, right? You can do just a structure command. It gives you the information about the various data sets. For example, movies, it has movie ID, variable movie ID title, which is a factor. And movie IDs are 1, 2, 3, 4, 5, 6 like that. Genre, and it's also a factor. There are 902 levels. Okay, distinct levels are there. Ratings, user ID is there, movie ID is there. Rating is given a number which varies between 1 to 5, and then timestamp. Don't worry about timestamp. We are not using it. It is some number of seconds starting from base time. Okay. The links are movie ID with respect to IMDb versus Tomato movie database, and then tags. Okay, the tags that we saw. So all those things are here. Excellent. Okay. Any questions so far? And I think we are ready to go do some data wrangling. Okay, because this data as it is, you can't use it. You have to wrangle. That means make sure that you kind of herd the HERD, herd the horses, right? Like that, herd the data into a way. Sometimes people call it as massaging. It's not really massaging. Data wrangling is a better word. That's a more modern word. So we kind of bring together the data in such a way that we can use it for our intended calculations. Okay. All right. So there is some data wrangling going on, but so what I want to do is I want to separate out the pipe symbol. You remember that pipe symbol? I want to say that gives you multiple characteristics, in terms of the genre. So I want to separate it out and write it as each one as a separate column. Everybody understands? That's what I'm doing here. So from genre, I create genre 2. And I write it out as a data frame, but then split the genres in multiple columns. That's all I'm doing it. Okay. So here it is done. And then I create a matrix, a column representing each unique genre and indicate a genre was present or not in each movie. Okay. And I looked into all types of genre, and it turns out to be something like 18 genre types. Okay. So you can see that these are all genre: Western, noir, thriller, sci-fi, all those things. I just looked into it, figured it out by finding out all different distinct genre. Okay, so I create a matrix of data where I want to create a matrix where I have the now the matrix size is 9126 because there will be a title row also, right? The header row, and then 9125 movies, 18 columns of genre. You see how I have done it here? Okay, the genres are coded on the header, and then I will have yes or no, 0 or 1. If it is 1, that genre belongs to the particular movie. If it is 0, it's not. That's what I'm trying to create. So let me finish this one, and then I will show you how the data looks like. Okay, remember I have to start all the way from here. All these lines I have to run to get that. Okay, so let me run that. Check, 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 check. That's it. Now iterate through the matrix because I have to put. Let's see what is first of all genre matrix mean. Let's open it and see. Okay. Genre matrix. Matrix 3. I don't want matrix. I want just matrix. Matrix 3 is more advanced calculations. So right now I just want to see genre matrix. Okay. So it should be here. Genre matrix. So this is what genre matrix. So you see this one for each of the movies. I'm saying. So it is 9126. You remember that? Okay. Even though there are only 9125 movies, because in the top row is still as kind of header. Okay. So number 2 is the Toy Story in this case. So what is that? No, it's not written yet. I have just created the matrix. Now I'm going to post it. Okay. Whatever the genre coming in, that's what I have to do. So let me go to the. So far so good, everybody. Just give me some input, please. The more you give input, it makes it easier for me to interact with you. Okay. Yes, thanks a lot. But you don't hesitate. Just give. When I ask you, just do it. Yes, no, looks something like that. Okay. Thank you. Don't hesitate. You are the best. You make my life exciting, man or woman, whatever. Sorry. I like that kind of expression. Man, how are you doing? Like that. All right. So I just created the matrix. Now I have to post it that particular genre exists or not. Okay. Now let's do that. Now I have to go back to the program. Is there a video recording of this one? Please. This is extremely informative. Yeah, I'll post it. Don't worry about it now. Okay. Just listen very carefully. Okay. Yeah, of course I'll do it. I don't used to do it before, but I'm going to do it now. Okay. Then I'm going to post I said, right? I'm going to put the wherever there is a. How will I identify the genre, whether that particular genre is there or not, right? By reading each one of them, by reading each one of the records, and then making sure read that particular the particular word, the phrase is there, like the genre is, it says thriller, I put it 1 there. That's what I'm trying to do here. I iterate through the matrix now, convert into a data frame, genre matrix 2, and then head genre matrix 2, and then I still do something about 0 or okay, let's do up to this now. I created from genre to genre matrix 2. Let's run it. It's running. Okay, it's done. You see this one? It's just a head. First 5 lines of data alone I posted. The first movie is Toy Story. You see the highlighted one? Okay, I think it is adventure, it is animation, it is children, it is comedy. Now we split all those words into these columns of 0 and 1. Okay. Now, all right. Now what I want to do is, there are 2 ways I can do calculations. One is a simple calculation, yes or no, whether somebody liked the movie or not, right? Like a thumbs up or not, right? Like the movie or not. So liking means 4 and 5. If the score is 4 and 5, it is liking, thumbs up. If it is less than 4, that means 1, 2, 3, then it is, they kind of thumbs down. That means they didn't like it. So I want to put that kind of codes, -1 and 1. Okay. So I'm again doing some conversions of ratings. Okay, and I do that here. Binary rating. I make the ratings into a binary class. Yes or no, or 1 or -1. Okay. And then I will show you the headings. Okay, head, that means just top 5 or 6 observations. Let's run this one. It's running, so let it go through. See, it has to do for 9,200 movies, right? 9,125 movies for every one of the evaluations people have done. and then I still do some more additional. Yeah, I have to do some kind of a reshape, of the data. So which I will do that here. Binary, that is called binary ratings 2. So ratings to binary ratings 1, and then binary ratings 2. Only basically I'm doing the reshape so that I can do some inner product calculations. You remember that the dot product, all those things, cosine similarity, I can do all those things. And I have to arrange it in such a way that the columns of one, I can use the columns of another one to do the inner product, or rows of one with another rows of another data set. Okay. So it is still running. Okay. But you see how I am taking with a very simple small data set explanation to big scale. Okay, big scale. It can be actually done for millions of records. In website analysis, in product analysis, if you have a large store with a huge stock, you will do that. Same thing. All right, so binary ratings, I did that. Right now, just I did the binarizing. I did the binary made into binary. Okay, that's all. So user ID, 7 didn't like the movie. His rating is -1. That you remember I said that when I was explaining the ratings. 7 user ID 7. He didn't like the movie, the Toy Story. He didn't like it. If you remember, I said, "Oh, he said okay." But the user ID 9. So didn't like means what? -1 means the score he gave was 1, 2, or 3, not 4 or 5. The user ID gave 4 or 5. That's why his rating turns out to be 1. Okay. All right. So I can go back and show you, right? If you want, let's do that. See, user ID 7, he gave 3. That was the issue, right? We said 3 or 4. 1, 2, 3 will be considered as thumbs down. So he rated movie he or she rated movie 1, Toy Story, into less thumbs down, basically. That's -1. But on the other hand, 9 user ID 9 gave 4, so that's why it is 1 here. Okay, so we have accomplished what we wanted to do. Let's go back to the recommendation engine more and more. Let's do the binary ratings 2. We want to do the binary ratings too. I'll explain. So basically, I'm reshaping the data. Okay. So see, this is an ugly shape. I can't use this to do some inner product. So I want to do it in kind of matrix type, right? That's what I'm doing here. And then I will show you 6 lines of output. Okay. So it's working. It's done. Now you see it is written in this way. What is the way? That is, let me show you the dimensions. Maybe you will be able to appreciate that. And row binary ratings 2. $9,066. Something fell off. Okay, why? Because we don't have ratings for all the movies. That's what it is. Everybody, so far so good. So that many number of rows, but how many columns? N columns. So it should be the number of users. Okay, yeah, 671. 671 raters. Okay, so the data is reshaped into movies are rows, and the columns are the raters information. Okay, so n column binary ratings 2. That's what for now. That's why it looks like this. Okay, it is 672 only because it is giving the index column also. Okay, I think it is index column 2. 672. One moment. All right. Now, so I have positioned the data. Now I'm ready to do the. Yes, that is correct. You are right. Yes. Okay. Somebody asked the question that you are using. You are showing only 6 rows, but then you are executing all the rows. Absolutely, you are right. Okay. Any other question? I can stop now because I think we have come very nicely to to do the the inner products and all those calculations we talked about. and then go and select the neighborhood calculations, kn and 3, instead of kn and 3, maybe we'll use kn and 10 or something like that, and then, and then start recommending it. That's it. Okay. Now, so I'm going to do all those things now. Let it go through. Remove the rows that are not rated. So we did remove the rows, so that's why not every movie got ratings. No, there is nothing you can do, but there is no rating at all. Okay, so we can't use that information. So I'm going to do all these things for now. Okay, and then what am I doing here? Calculate the dot product. You remember I talked to you about dot product, all those things. The cosine similarity. Okay, and then I do the after I do the cosine similarity, I do the neighborhood calculations, neighborhood averages of the most important most closest people. That's what I do. Okay, let's just run that one. I hope I have selected all the remaining things. Yeah. It will take some time, but oh, it is done. Pretty good. Okay. Now I just have to do the results too. First user profile, first genre profile, similarity matrix. There are some very intriguing work you have to do because it is it's what is called the Jacquard matrix. So in this case, he is using Jacquard measure, not the cosine similarity. See, cosine similarity has to have a continuous data, but I converted the data into thumbs up, thumbs down, right? Thumbs up, thumbs down. Remember that I have converted the data into thumbs up, thumbs down. So I can't use cosine similarity. There are different similarity measures I can use. We will use what is called the Jacquard similarity. What is Jacquard similarity? I'm going to explain that to you. Calculating, and why did I use Jacquard similarity, not the cosine similarity? Again, it's because I converted them into thumbs up, thumbs down rather than continuous score. If I had used 1 to 5, then I can use cosine similarity, but I didn't use that way. Okay, because I converted into thumbs up, thumbs down, yes or no, I like it or not. Binary type, classification. I have to use a measure like Jacquard similarities. There are other measures also, but Jacquard is very popular. Okay. All right. So I do some, I have to work with some distance matrices because now the method is Jacquard distance that I'm going to use, right? Which is a different type of calculation, and I am scaling it. I have to use, some package called proxy, and then I will use Jacquard similarity to calculate. And there are some number of elements in that matrix. There are some, reshaping. I have to do all those stuff. Okay, and so now after I do the Jacquard similarity, I print the results. Okay, let's do that. It's a huge matrix, so it may take a little bit of time, but I will finish it, pretty soon in another few minutes. So there you go. So the movie is, the recommended movie for the first rater, okay, whoever that rater ID is, first rater, the recommended movie ID is 7625. Remember, there are 9,000 plus movies, right? 7625, and that movie name is this. Isn't it cool? Now say yes or no. Isn't it cool? I found the movie recommended to this individual, whoever that individual is. The individual is the first rater. Okay, cool. Somebody said cool. Thank you. All right. Okay, so I can do more than that, right? So I can do more than one movie. That's what I'm saying. But so I can do all these things, and I can recommend more than one movie. And again, there are some reshapes I have to do. So that's how we do it. But here is the thing: there is a package called Recommender Lab. Okay. And there it provides some of these, some of these facilities for us to do. I don't have to do the calculation myself. A lot of things, it uses cosine similarity with ratings. It's called user-based collaborative filtering. User-based collaborative filtering, and it uses standard 30 observations and neighborhood observations, not 3. I used it in the example. 30, it uses 30, and then I can use that to do top 10 recommendations. Everybody understood what I said? There is a recommended lab package you can use, and that's what recommended lab. Recommended is a function here. Recommended lab package. Everybody, please give me some input. Everybody understood what I said? So instead of me calculating all these things, I can use a recommended package. I can, and it uses 30, 10, 20, 30 neighborhood observations to calculate the the average recommendation, and accordingly it can give you 10. It is also I can fix the 10 or 5 or 20. I can do user-based collaboration. Yes, Mr. Aditya. Okay. That's what is done, and I want to give you a little bit of information about because of time, I'm going to give you a little bit of additional information on how do we determine whether our recommendation is good or bad, right? Good or not. So I will talk about it as performance metrics here, and this notes is good in that sense. So these are the, let's say, there are 3 performance metrics which are good, which are commonly used. Okay, one is called accuracy. The other one is called precision. Third one is called recall. These are the 3 things we use. There are also a F1 measure, another very important measure, F1 measure. But I'm going to talk to you only 3 today, and then close this session. Okay. The accuracy is number of items correctly classified, versus the total number of items. The total number of items. Out of that, how many of them are correctly classified? So, in other words, I do the analysis. I have a test data set, right? I do the analysis and I post this ranking, and then I say these are the 10, top 10 or something like that. And then I go back and see whether those movies are recommended. Those movies are, how many movies are recommended correctly on that. And out of for let's say I have done total of 10,000 recommendations for, let's say, 100 people or 1,000 people, then how many of them correct versus the total number of items available, in this case 9,125, right? So that percentage is what is called accuracy. That is one way. Okay, that is one way. The other one is what is called the recall. So number of movies people liked and versus liked and shown to them. Okay, so if I like these are all about test data set, remember that. So I know how many more movies I like, right? And then I compare with the the recommendation engine. Out of I like 10 movies, out of it turns out in my test data set, but then I belong to the test data set, okay? And I like 10 movies, a specific collection of movies, but then only 3 of them, 5 movies I like, and then only 3 of them are shown. That is called recall. So you see the difference between this and this, everybody. Do you understand the accuracy versus the recall? Somebody is asking a question. One moment. Can content-based filtering be done on recommended lab? I'll have to look into it. Okay, but this one is user-based right now. I would say yes. Okay, if I had to take a shot at it, I would say yes. But this example is right now user-based. Okay, I can answer that later. Right. But my question was, did you understand how to evaluate the performance? Everybody? Anybody? Any questions? So far, I explained only 2 things. One is, okay, thank you, Aditya. Aditya is pretty good. You have been very responsive, Aditya. I want everybody to be like that. Go. Okay. Everybody understood the accuracy and recall, right? I will leave it to you, the precision talk. How about that? Or I can. In prediction, there are 5 important performance metrics that a data scientist would use to measure the goodness of classification models. The recommendation engine also belongs to a classification model type, because we identify a product to be a recommendable product because the customer will act on it as favorable or unfavorable the way we predict, and hence it is a classification model. And these are the 5 different performance metrics that are used in general to measure goodness of prediction or goodness of the recommendation engine. The first one is the area under the receiver operating curve. I will define that. The second one is accuracy. Third one is precision. Fourth one is recall. And fifth one is F1 measure. I commonly see that as F1 measure. Some people have used it as F also. So let me define what is meant by receiver operating curve. The graphics is coming from dataschool.io. So if we have a distribution of, let's say the blue is the distribution of negatives, and the refers to the negatives, and the positives are, the red colored distribution. Okay, and then these are the prediction probabilities. So the threshold is, let's say 50.5. If the predicted probability is, more than 0.5, we categorize it as belonging to yes category or positive. If it is less than 0.5, we categorize it as belonging to negative category or no. Okay. So at this time, the area the area to the right of this 0.5 is on the positive curve is the true positive. Okay. On the negative curve, it is the false positive. Okay. On the what are the area we have here, that is the probability of false positive. This is the probability of true positive. All the probability in red area after 0.5 is true positive. In blue probability distribution after this threshold is the false positive. So in fact, false positive, we are fixing it as 0.5. Okay. So in this case, true positive, with a given example, if there are 250 samples, and if there are 235 are correctly identified as positive, they are coming from positive side, and then we predict it as positive 235 of them, then that is called true positive, which is 0.94. The false positive is 125 of them belong to the right of this probability distribution, blue color probability distribution, which is 125. That's why it is 0.5, because we actually fixed it also. So it's 0.5 is the false positive rate. So if I take, this is the false positive rate, this is the true positive rate, usually it comes on this side, but there is no space here, so we are representing it here. This is the EQ probability case, EQ probability case randomly. If you toss a coin, which one it belongs to, right? Yes or no. That is the, which one you will categorize it yes or no is the EQ probability case. That is the random cause of toying. This is the negatives, and this is the false positives, and this is the true positive. Okay, so when we have 0.5, the true positive rate is 0.94, and that is what the point on the ROC curve is. So for every point on this one, I can calculate this true positive and false positive, and that forms the receiver operating curve. Okay. So after classification, what we get confusion matrix. This is created based on a threshold point. In this case, in the previous example, the threshold is 0.5, right? We explained 0.5. So on the basis of that one, I will find out how many of them are true positive, how many of them are false negative, how many of them are false positive, and how many of them are true negative. So this is basically the predicted S's. I'm taking it as a column wise, predicted no here, predicted yes here, predicted no here, and the row wise I'm taking original yes and original no. So when original S is N1 plus N11 plus N12, out of that the predicted S identifies the N11. Then our true positive is N11 are the true positives. They are originally yes. We are also predicting it as yes, and then the original is yes, but we predict is no is false negative, because we are falsely classifying it as negative, even though the original is yes, so it's called false negative. Okay, likewise, the original is no and predicted is yes means we are falsely categorizing it as positive. Originally it is no, but then we are categorizing it yes, so that's false positive. And then finally, original is no, predicted is also no, so that is called true negative. So in terms of using these things, we can clarify quickly, classify, measure what are the true positive, accuracy, precision, recall, and F1. So accuracy is the percentage of sum of targets and references that are correctly predicted among both targets and references. So among both targets and references means grand total. Okay, that is the in the previous case, it refers to all the total. The true positive and true negatives are the diagonal, so diagonal one, and that is the correctly identified. So we are talking about the percentage of that are correctly predicted among both the targets, both positive and the negatives. So with respect to the grand total, so that is called accuracy. Precision is it is the percentage of true positive among the predicted. Among the predicted only we take among the predicted is we are talking about among the predicted yes category, right? And then true positive is then the column wise, right? The true positive is the first diagonal term divided by the first column total is the precision. On the other hand, the recall is it is a percentage of true positive among the targets. The targets are yes. Among that, total is n11 plus n12. You remember that is the first row summation. So the true positive divided by the first row summation is the recall. Okay. So the difference is it is precision is the percentage of true positive among the predicted. Recall is it is a percentage of true positive among the targets. Okay, among the targets we are how much we are able to recall. Okay, and the F1 refers the average of precision recall because there is no reason why you have to give priority to one or the other. Definitely you don't give priority to accuracy if the one of the category is heavily loaded, which is usually the case for true negative. Usually targets are smaller size. So then it will give a very biased result. You will say I have accuracy achieved 90%, but in fact your true positive can be only your recall can be only 50%. Okay. So the F1 is the average of precision recall because both precision recall are rates. Here is a great example of harmonic mean, and in fact F1 is the harmonic mean of precision and recall. Okay.